Hi friends, today I am going to explain the second concept of second algorithm of line drawing algorithm, that is Bresenhams line drawing algorithm. In previous video I explained the concept of DDA, that is the digital differential analyzer algorithm. So here I am going to discuss the Bresenhams line drawing algorithm. So in the initial point of this algorithm is to taking the two coordinates, that is the starting and ending coordinate is the common, because of without these two coordinates we can't move the procedure, or we can't take the line in between the coordinates. And the next important point is how many coordinates are derived in between the two given starting and ending coordinates. So here is the way we can derive the coordinates is an entirely different pattern compared to the DDA algorithm. So the procedure is the same procedure, but the notations are the different compared to the DDA and the Bresenhams drawing algorithm. Here we need to find some of the intermediation coordinates in between the starting and ending coordinates. So this algorithm mainly focus on one of the value, that is a decision parameter pk value. So now you make it identified in slope value of DDA. DDA derived the slope value m, where m equals to delta y by delta x. That is already we observed in the DDA algorithm. But coming to this Bresenhams line drawing algorithm, it may depends on the decision parameter, that is the pk. So how we will calculate the intermediation coordinates in between the starting and ending coordinate, how many number of intermediation coordinates are derived in between the starting and ending, and the third one, how we will calculate the decision parameter pk. Now we are going to take the procedure. Now in the first one, similarly you can take the procedure with the starting of the starting coordinates and the ending coordinates x naught y naught and x and y naught. So this is the common procedure you can observe in the DDA also, because of without taking the coordinates. So there is no procedure to take between the starting and the ending. Because of only the initial point and the end point only, we can derive the number of coordinates. So here is some of the notations are defined by the Bresenhams. A Bresenhams algorithm is the popular algorithm for line drawing algorithm, and similarly the circle algorithm also. Now we will focus on this particular line drawing algorithms of Bresenhams. So first we can calculate the values of delta x and delta y. This is the similar pattern of the DDA algorithm. Here is the delta x is nothing but the differential of x values, delta x equals to xn minus x naught, and the delta y is nothing but the differential values of the y values, that is delta y equals to yn minus y naught. So here one more value we can find, that is the decision parameter pk, where the decision parameter only can decide the number of coordinates in between the starting and ending point. Now you can observe the decision point, the decision parameter pk is calculated by pk equals to 2 into 2 delta y minus delta x, 2 delta y minus delta x. Already we know the differential values of the x values, the differential values of the y value, that is delta y. So here we can easily calculate the decision parameter pk. So the pk equals to 2 into delta y minus delta x. Here we can find the next coordinates with the depends on the that is decision parameter pk only. So how we can calculate the decision parameter? Here we can observe that is pk equals to 2 delta y minus delta x. But here the difference between the DDA and here is, so here every time the decision parameter changes rapidly, that is based on the given coordinates. So based on the derived coordinates, then the pk value may be changes. Now you can consider then the current coordinates are the x naught y naught, and the next coordinates are x and y n. Then we can take the decision parameter pk then the procedure should take the two more cases. So the two more cases are derived, the Bresenhams depends on the decision parameter pk value. So now you can observe this particular procedure. The first case is if the pk is less than 0, the pk value is less than 0, the decision parameter less than 0, then here you can calculate it not only the x coordinate, next x coordinate, next y coordinate, not only these two, we are also calculated the pk plus 1, next decision parameter value here also we can calculate it. So this is the major difference between this Bresenhams algorithm and DDA line drawing algorithm, because of here based on the derived decision parameter value pk, it depends on the value, then we can calculate the not only the next coordinates, we also calculated the next decision parameter. That's why it is better than the DDA algorithm. Now in this case, how we can calculate the next decision parameter pk plus 1 equals to pk plus 2 into delta y. So these all values we know that pk value is the decision parameter value which is calculated by delta y by delta x, and here we can substitute the value, then we can derive the next pk value, pk plus 1 equals to pk plus 2 into delta y. The next coordinates of the x and y coordinates are x plus 1 equals to, so here the xp plus 1 and yp plus 1 equals to yp only. So here the some of the notations are these standard notations to calculate the next coordinates from the given value. So here if the first case is pk is less than 0, pk is less than 0, we can calculate the pk plus 1 equals to pk plus 2 into delta y, and xk plus 1 equals to xk plus 1 and yk plus 1 equals to yk. So these values are taken at the condition if pk value is less than 0. And coming to the second case, the second case is nothing but the pk is greater than or equals to 0. Both conditions are taken here, is greater than 0 or equal 0. So if the value is greater than or equals to 0, that is a pk value, then we go for the next parameter, decision parameter value, that is pk plus 1 equals to pk plus 2 into delta y minus delta x. So here the next parameter is calculated, pk plus 1 equals to pk plus 2 into delta y minus 2 into delta x. So the next parameters, the next coordinates of the x and y are xp plus 1 equals to xp plus 1 similarly, and yp plus 1 equals to here yp plus 1, that is also the incremented value. Now you make it identify the difference between the case 1 and case 2. The next parameter values are the different, the next next coordinate values are the different in the case 1, and similarly in case 2 also the next parameter, finding the next parameter is the different standard, and the next coordinates also takes the different standard. So here we can decide the number of coordinates based on the pk value. So the pk value also changes rapidly based on the given condition. And what the next step, that is step 4 in the procedure, is keep this step that is a 3 until we reach the last coordinate or the ending coordinate. So here we also calculated the number of iterations. In DDA, how we will calculate the number of iterations in between the starting and ending point? That is always we can find if absolute value of delta x less than or greater than value of the delta y. So based on that absolute of delta x and delta y only, we can decide the number of steps, number of iterations in between the starting and ending point. But here a standard method to calculate the number of iterations in between the starting and ending coordinates are nothing but delta x minus 1 times. Already we calculate the delta x is the differential values of the x coordinates, and the here delta x minus 1 times in the sense, suppose if the delta x value is 5, delta x minus 1 in the sense 5 minus 1, that is the 4 times. That means the 4 iterations are derived in between the starting and ending coordinates. So this is the procedure. Now we can take this procedure with the help of the some of the example. Now before we take this example, we need to understand again the points of the Bresenhams line drawing algorithm. In that, the first one, the starting and ending coordinates are x0, y0 and xn, yn, and we will find the delta x value and delta y value, where delta x equals to xn minus 0, delta y equals to yn minus 0, and here we can find the decision parameter pk value. So the decision parameter pk value is taken pk equals to 2 into delta y minus delta x. That is the given standard notation of Bresenhams algorithm. So now based on the pk value, so the Bresenhams calculated the two cases. What the two cases? Case 1 is equals to pk is less than 0, then it takes the next decision parameter and the next coordinates are the different calculation. And second one, if the pk is greater than or equals to 0, then we go for the next decision parameter value pk value and the next coordinates, that is the xk plus 1 yk plus 1 value. Now we are going to explain this algorithm with the practical example, because the given coordinates, which is very easy to understand the concept based on this example only. So when we take the example, then the algorithm may takes a different criteria for the solution of this particular drawing a line on the screen. And coming to this practical example, now we take the starting coordinates are 9, 18 and the ending coordinates are 14, 12. That is a given problem. So what are the starting coordinates? 9, 18. So 9 is the x coordinate and the 18 is the y coordinate of the initial, and the 14 and 22, 14 is the x coordinate and 22 is the y coordinate for the second and or ending coordinates. Now we will calculate it, what the values is delta x and delta y value. So where delta x equals to, we know that xn minus x0, that is equals to given values 14 minus 9, which equals to 5. Delta y equals to yn minus y0, which equals to 22 minus 18, so which equals to 4. So now we can calculate the decision parameter pk. So the decision parameter pk equation is 2 into delta y minus delta x, so which equals to 2 into 4 minus 5. So 8 minus 5, which equals to 3. So the decision parameter value is 3. Now here we will find the two identification. One is how many number of iterations are derived in between the starting and ending point is, that is delta x minus 1. We already identified, that is in the step of the fourth step of the procedure. In the fourth step, it derived the number of sequence of steps or number of iterations in between the starting and ending coordinates are nothing but the delta x minus 1. Here is the delta x is the 5, delta x equals to 5 value, 5 minus 1 equals to 4 sequence of steps are derived in between the starting and ending coordinates. And here the calculated the decision parameter pk value. So the pk value equals to 2 into delta y minus delta x, where delta y equals to 4 value, delta x equals to 5 value. So the pk value is also derived. So the based on the pk value only, we can calculate the number of next iteration and the next decision parameter. So now pk, you can observe the pk is greater than 0. The greater than 0 in the sense, we go to the second case. We go to the second case for calculations of the next decision parameter and the next coordinates. So the next decision parameter pk plus 1 equals to pk plus 2 into delta y minus 2 into delta x. That is for the case 2, we will find the next decision parameter, which equals to 3 plus 2 into 4 minus 2 into 5 equals to the final next pk value equals to 1. And the next coordinates xk plus 1 equals to, so xk plus 1, so initial coordinate is the 9, 9 plus 1 equals to 10, and the next y coordinate yk plus 1 equals to yk plus 1, which equals to 18 plus 1, which equals to 19. So similarly we can continue this process until the last point is reached. So up to the last point we will calculate the next coordinate and the next coordinate and the next coordinate and so on until the last coordinate is reached. Last coordinate is nothing but already given the ending coordinate of 1 x and y intervals. Now we go to the number of iterations are we already calculated, that is delta x minus 1, that equals to 4. Now we go to the in detail of calculation of the next decision parameter and the next coordinate. The initial coordinates here you can observe 9, 18. So that is the given coordinates, and based on that we will find the decision parameter pk value, that is already we derived, that is 3. So at the 3 value decision parameter, what is the next parameter? Because of pk is greater than 0, we go to the second condition. Then the next parameter we will find only the 1. So that is the equation, we can substitute the values and finally we get the next parameter, that is the pk plus 1. So here the next coordinates are both are the incremented value when it is greater than 1. That you can observe here in this case. Now you can observe here, if the second case pk is greater than 0, then the x coordinate and the y coordinate both are the increment, and the decision parameter pk plus 1 equals to pk plus 2 into delta y minus delta x. Now you can take that procedure. We will continue until the last ending point given is 14, 22. So if we are getting the positive value, pk value is positive value, then the next coordinate values are the incremented value, that is the xk plus 1 equals to xk plus 1, yk plus 1 equals to yk plus 1. If it is the less value, that is less than 0 value, less than 0 in the sense the minus values. So the negative values are taken. So if the negative values are taken, the x coordinate is incremented, xk plus 1 equals to xk plus 1, but yk value is similarly we can take the yk value. There is no increment of the yk value if the pk value is less than 0. So remember this condition, it is very important of these particular notations. If the pk is greater than 0, the x and y coordinates are incremented coordinates. If the pk value is less than 0, so that is the minus 1 or any minus 2 or anything less than 0, the x coordinate values are the incremented value, that is xk plus 1 equals to xk plus 1 and yk plus 1 equals to yk. So the y incremented value is nothing but the yk only, there is no increment. So here the yk only we can consider. That's why in the minus 1 value we derived that new pk value is 7, but the incremented value of the x is taken 12. But the y increment is doesn't take it, as it is that yk value is taken, that is the 20 value. Here the 11 value is incremented, that is 12 value for the minus 1 value of the pk. Now the remaining, if the 7 is the next pk value, in the next iteration this is the initial decision parameter, that is 7. So we can calculate the new decision parameter. In the next iteration we will find the 5 is the initial decision parameter. So at the 5 we can reach the 14, 22. This is the final destination or the ending coordinate. Now we go through the graph. This is the graphical representation related to the given coordinate. So now you can observe this is the better line compared to the DDA. So because here every time the pk value is changes, then only so we can take the iterations, number of iterations or the coordinates in a different manner compared to the DDA. So now this is the graph which can be represented a line by using the Bresenhams algorithm for the given coordinate and the first and last coordinate. So based on the x values, so are taken the x coordinate and y values are taken the y coordinates, and the values are taken, and finally we can derive the line drawing on the screen only. So now this is the Bresenhams algorithm compared to the EDA. It is the much better algorithm because of every time the decision parameter value is changes, and here we will take the only two conditions based on the parameter pk value, pk less than 0, that is for first case, and pk is greater than 0, that is the second case, and we will find the delta x and delta y is the similar of the DDA, and we can find the pk equals to delta y by delta x, and the remaining the next coordinates will be taken with based on the pk value, where pk is less than 0, it takes the derive the next decision parameter value and the next coordinate value similarly. And here pk is greater than or equals to 0, it takes the case 2, and it also derive the next pk decision parameter and next coordinates, that is an x and y coordinates. So these all are the derived values which can take a particular line drawing with based on the given coordinates. So I will explain in the next slide the concept of the midpoint line drawing algorithm.